Alright, folks, welcome to the evolution of Earth with a South African twist. We're talking billions of years here, from the fiery start at 4.6 billion years ago, through ancient eons like the Hadean and Archean, up to today. I'll break it down by name origins, what was happening globally, and how it ties into South Africa's rocks and history. Let's jump in. Earth's history is split into time zones. Eons, like the Phanerozoic, are the biggest. They span billions of years. Eras, like the Mesozoic with dinosaurs, zoom in, spanning millions of years. Periods get specific, like the Cretaceous for flowering plants. Epochs, like our Holocene now, are the smallest, and detail changes over thousands of years. The timeline starts with the Hadean Eon, from 4.6 to 4 billion years ago. It is named after Hades, the underworld, because Earth was a total hellscape, molten lava everywhere, bombarded by asteroids, and a poisonous atmosphere. Globally, that's when our planet formed from space junk, and the moon got knocked out by a huge collision. In South Africa, we don't have rocks from this time. They're all gone. But tiny zircon crystals give clues that crust might have started forming toward the end. Next up, we have the Archean, spanning from 4 to 2.5 billion years ago. Archaios means ancient in Greek, and it's certainly a fitting name. Earth's crust had finally cooled down, but there wasn't any oxygen just yet, only early life forms like bacteria in the seas. Worldwide, that's when stable land started to form. Here in South Africa, the Kapval Craton became a solid chunk underneath us. The Barberton Greenstone Belt holds some of the oldest rocks with signs of microbes. And the layers of the Witwatersrand brought all that lovely gold we mine today. So, the Proterozoic, earlier life, as the Greeks would have it, from 2.5 billion to 541 million years ago, mark the arrival of large quantities of oxygen, known as the Great Oxidation Event. Continents grew, and life got more complex. Early animals start to appear. Supercontinents formed and broke apart, and there were global ice ages. In South Africa, the Transvaal supergroups got all those iron and manganese ores, and the Bushveld complex erupted with platinum and chrome riches. Mountains built up in the Namakwa natal belt, and the Nama group down south. It's got some of the very first multicellular fossils, just before the Cambrian. Right, let's dive into the pale Proterozoic, shall we? That's 2.5 to 1.6 billion years ago, ancient earlier life. And it's when the Great Oxidation really hit. Oxygen just filled the air. Continents bulked up. And oceans, well, they made those banded iron layers. Down in South Africa, the Transvaal supergroup laid down iron and manganese. The Bushveld igneous complex formed with all its platinum and chrome, and tectonics tweaked the Kapval Craton. It's all quite fascinating, really. Mesoproterozoic, from 1.6 to 1 billion years ago, is right in the middle of the Proterozoic. Cratons are locked in, and supercontinent Columbia assembled. Photosynthesis continue, and algae become multicellular. In South Africa, crust grew south, forming the Namakwa Natal Belt through major mountain building. Right then, the Neoproterozoic, spanning from 1 billion to 541 million years ago, or new earlier life. It was a time when the supercontinent Rodinia assembled, then broke apart. Earth experienced those dramatic snowball glaciations, and the Ediacaran critters emerged as some of the earliest animals. In South Africa, we find the Nama group with those remarkable early fossils, alongside glacial deposits in the Gariep Belt, which leads directly into the Cambrian explosion. We're now in the Phanerozoic Eon, which began some 541 million years ago. It means visible life, because fossils are just everywhere. Life really exploded in the Cambrian period. Plants developed on land, Dinosaurs ruled and then died off. Continents shifted to today's configuration, and mammals, including us, took over. In South Africa, the Cape supergroup has thick sediments and fossils. The Karoo holds glacial and reptile records. Dinosaurs left tracks in the sands, and in the Cenozoic, uplift shaped everything while the cradle of humankind shows us our ancestors. The Paleozoic era, meaning ancient life, spans from 541 to 252 million years ago. During this era, the seas teemed with all sorts of critters, and on land we saw the emergence of forests and insects, all truly beginning with that incredible event, the Cambrian explosion. The continents gradually came together to form Pangaea, and then it all culminated in the biggest extinction event our planet has ever known. Now, if we look at South Africa's Cape supergroup, it beautifully displays marine and delticus sediments in formations like the Table Mountain and Bokkeveld groups. Meanwhile, the Karoo's Duiker provides fascinating glacial evidence, hinting at Gondwana's journey over the pole. The Cambrian period lasts from 541 to 485 million years ago. Cambrian is the Latin name for Wales, where the rocks were first studied. And what a boom time for life it was. We're talking trilobites, all sorts of shelled critters, even early fish. Just this sudden burst of diversity in the oceans, simply remarkable. Now, here in South Africa, we don't have much in the way of direct rock from that period. But the very base of the Cape supergroup's Table Mountain group, well, that might just date back to this time. Though it is rather tricky to pin down precisely. The Ordovician period, 485 to 444 million years, a name actually from a Welsh tribe. The seas just buzzed with life, and actual plants appeared. But, alas, it all ended rather icily, with a mass extinction. In South Africa, glacial signs, things like drop stones, are found within the Cape supergroup, suggesting that Gondwana was positioned quite near the South Pole at this time. Silurian, from 444 to 419 million years ago, another Welsh tribe name. During this period, plants with veins hit land, reefs grew, jawed fish evolved, and things warmed up with higher seas. Now, in South Africa, the Cape supergroup kept building with marine layers, but I must say, fossils from this particular time are rather rare. The Devonian period, from 419 to 359 million years ago, is named after Devon in England. It was a time when the fishes ruled the seas, forests began to sprout, and vertebrates started to appear on land, while the continents were beginning to squeeze together. Now, if you look at South Africa's Bokkeveld group in the Cape, it has some splendid marine fossils, like trilobites, and hints of early land life. The Carboniferous, that's 359 to 299 million years ago. It's called coal because of those absolutely huge swamp forests in the north. You had giant bugs, early reptiles, and ice all over Gondwana. Now in South Africa, the Karoo's Duiker group actually shows us these massive glaciers with scratched rocks and fascinating boulder deposits. The Permian period, from 299 to 252 million years ago. It's named after the Russian region Perm. Now, Pangaea, the supercontinent, was well and truly locked in. The lands dried out, and it all ended with the worst extinction event ever, killing over 90% of all sea life. In South Africa, the Karoo saw even more dry conditions building on earlier glacials, really setting the stage for the next era. The Mesozoic era, meaning middle life, from 252 to 66 million years ago, saw the rise and dominance of the dinosaurs, the emergence of early mammals and birds, and the appearance of flowering plants. It ended dramatically with the asteroid impact that caused a mass extinction. In South Africa, the Karoo Basin preserves this record in the Elliott and Clarence formations. which contain fossils such as Massospondylus. The Drakensberg basalts mark the massive volcanic activity associated with the breakup of Gondwana. The Triassic period, from 252 to 201 million years ago, is named for a three-part rock sequence first identified in Germany. Follows Earth's largest mass extinction, and life gradually recovered. The first dinosaurs and mammals appeared, and the supercontinent Pangaea began to break apart under predominantly arid conditions. In South Africa, the Upper Karoo Basin's Elliott Formation preserves early dinosaur fossils, with its red sandstones reflecting the region's dry climate and the onset of continental rifting. The Jurassic period, spanning from 201 to 145 million years ago, is named after the Jura Mountains between France and Switzerland. This period was dominated by dinosaurs, while birds evolved from small theropods. Sea levels rose, and Pangaea split into northern Laurasia and southern Gondwana. In South Africa, the Clarence Formation marks the final phase of Karoo sedimentation, followed by the vast Drakensberg basalt flows, volcanic eruptions linked to the continuing breakup of Gondwana. The Cretaceous period, from 145 to 66 million years ago, is named from the Latin creta, meaning chalk, after thick chalk deposits found in Europe. Flowering plants diversified rapidly, while dinosaurs continued to thrive until the mass extinction triggered by an asteroid impact. During this time, the continents gradually assumed their modern configurations. In South Africa, coastal basins such as Zululand and Algoa accumulated extensive sedimentary sequences as Gondwana finally fragmented, separating Africa from South America. The Cenozoic era, lasting from 66 million years ago to the present, means recent life. Following the extinction of the dinosaurs, mammals and birds diversified rapidly, becoming the dominant land animals. The continents drifted into their modern positions, global climates cooled, and repeated ice ages shaped the landscape. In South Africa, uplift and erosion exposed older rocks of the interior plateau, while coastal basins accumulated new sediments, setting the stage for modern environments and ecosystems. The Paleogene period, from 66 to 23 million years ago, is Greek for ancient born, and marks the beginning of the modern age. Following the extinction of the dinosaurs, mammals and birds diversified rapidly to occupy vacant ecological niches. The world's climate was generally warm, supporting lush forests even at high latitudes. In South Africa, marine sediments of this age accumulated in coastal basins, such as the Durban and Algoa areas, while uplift of the interior plateau began shaping the landscape we see today. The Paleocene epoch, spanning from 66 to 56 million years ago, marks the dawn of the modern Cenozoic world. Following the catastrophic extinction that ended the reign of the dinosaurs, life on Earth rebounded and diversified. Mammals, once small and nocturnal, began to evolve into larger and more varied forms, while early birds and flowering plants flourished in the warm, humid climate. In South Africa, gentle uplift and erosion shaped the post-Karoo landscape, and the first sediments of the emerging coastal basins were laid down along the developing continental margins. The Eocene epoch, spanning from 56 to 34 million years ago, represents one of the warmest intervals in Earth's recent geological history. Global temperatures peaked, supporting tropical and subtropical forests that extended far toward the poles. Mammals diversified dramatically, with the first modern groups of primates, horses, and whales emerging. In South Africa, continued uplift of the continental interior and subsidence along the margins influenced drainage patterns, while marine sediments accumulated in coastal basins, such as the Durban and Algoa regions, recording the ongoing evolution of the southern African coastline. The Oligocene epoch, spanning from 34 to 23 million years ago, marked a major climatic shift from the warmth of the Eocene toward cooler, drier global conditions. Antarctica became permanently glaciated, and sea levels fell as polar ice accumulated. Grasslands began to expand, supporting new grazing mammals and reshaping ecosystems. In South Africa, continued uplift of the continental interior enhanced erosion, while sediments carried by rivers built outward into the surrounding coastal basins, gradually shaping the modern coastal plains. The Neogene period, spanning from 23 to 2.6 million years ago, marks the continuation of Earth's cooling trend and the approach of modern climatic patterns. Grasslands spread across many continents, and mammals and birds evolved into forms recognizably similar to those of today. In Africa, the first true humans emerged, adapted to increasingly open and seasonal environments. In South Africa, uplift and erosion further shaped the interior plateaus, while sedimentation along the coasts continued to refine the outline of the subcontinent. The Miocene epoch, lasting from 23 to 5.3 million years ago, saw a dynamic world of shifting climates and ecosystems. Expanding grasslands supported herds of grazing mammals, while forests retreated in many regions. In Africa, early ape species flourished, setting the evolutionary foundation for the human lineage. South Africa experienced intensified uplift and river incision, establishing much of its present topography. The Pliocene epoch, extending from 5.3 to 2.6 million years ago, was marked by a further shift toward cooler, drier climates and the dominance of open savanna landscapes. Many modern animal species appeared, and early hominins, including Australopithecus, walked the African plains. In South Africa, cave and karst deposits from this time preserve vital fossils that trace the early stages of human evolution. The Quaternary period, beginning 2.6 million years ago and continuing to the present, encompasses the dramatic climatic oscillations of the ice ages and the rise of humankind. Alternating glacial and interglacial cycles reshaped continents, influenced sea levels, and drove evolutionary change. In South Africa, changing rainfall and vegetation patterns affected both animal migrations and the habitats of early humans, whose archaeological traces are preserved across the landscape. The Pleistocene epoch, covering 2.6 million to about 11,700 years ago, was defined by repeated advances and retreats of continental ice sheets. These climatic shifts tested the adaptability of species, including early humans, who developed new tools and survival strategies. In South Africa, cooler and drier intervals alternated with wetter phases, leaving a rich fossil and archaeological record in caves, dunes, and river terraces. The Holocene epoch, beginning 11,700 years ago and continuing to the present, marks the current interglacial period of relative climatic stability. This epoch witnessed the global spread of human civilizations, the rise of agriculture, and profound environmental transformation. In South Africa, Holocene sediments record the development of modern ecosystems, coastal dune systems, and the growth of human communities that shaped the region's recent history. Earth's geological timeline is a story written in stone, a story 4.6 billion years long. We divide it into time zones so we can understand the scale of change. The eons mark the grand ages, from the fiery birth of Earth to the age of visible life. The eras trace major transformations when oceans filled, mountains rose, and life conquered new worlds. The periods reveal familiar worlds, the ice ages, the rise and fall of dinosaurs, the shaping of continents, and the epochs bring us closer to the present, showing how life, climate, and humanity took their modern form. Every rock, every fossil, every continent is part of this timeline, a living reminder that Earth's story is still unfolding.